Okay, let's look at one of these conditional probability problems that, to me, are really enjoyable because they give us insight into one of the major applications of conditional probability. Helps us to gain some insight into what's going on with the mathematics behind drug tests, various tests for the presence of antibodies and that sort of thing. But let's look at this problem. There's Martians afoot. It turns out that 10% of the population is Martian. Most of these Martians are unaware that they are not human. For this reason, a test was devised to detect Martianality. Now, here's the key bit of information. We're going to see how we can use this to calculate some probabilities. When a Martian is tested, the result will be positive 85% of the time. So sometimes a Martian gets tested and the test does not detect it. So, and further, when a human is tested, the result will be positive 5% of the time. So apparently 5% of the time we get a false positive when humans are tested. Test says they're Martians when they're not. Now we're going to do an experiment here where an individual is selected at random and tested. Okay. Now, let's see, a good place to start here would probably be to draw a tree diagram. This way we take this bunch of words and we make a picture out of it. Maybe we can make more sense out of it. So, first of all, this experiment consists of selecting someone at random. Now, the individual we select is either a Martian or a human. So you can see that with a Martian, the probability of selecting a Martian is 10%. Probability of selecting a human is 90. The next thing we do, let's suppose we select a Martian. We test that Martian. Now the two options are they'll be positive, they'll have a positive test result or a negative test result. The probability of a Martian having a positive test result is 0.85. The probability of a Martian having a negative result is 0.15. The other possibility is we could choose a human and test them, and we could get a positive test or a negative test. A human will test positive with a probability of 0.05 and negative with a probability of 0.95. So what we've done with this tree diagram is we've drawn a picture of the information that we've been given. And hopefully that will make it easier for us to do some of our calculations. First of all, let's find the probability that the individual chosen will test positive. Now remember, there's a couple of ways that could happen. An individual could test positive if they are indeed a Martian. So we could select the Martian, test them, and get a positive result. That's one way we could get a positive result. The other way we could get a positive result is we could choose a human, select a human, and that human tests positive. Of course, we would get a false positive. So we see here that the probability of testing positive equals the probability of choosing a Martian and that individual getting a positive result given that they're a Martian, or we could select a human and get a positive result given that we've selected a human. Now let's look at, first of all, the probability, the first part, selecting a Martian and getting a positive result given that we've selected a Martian. Well, that's 0.1 times 0.85. Okay? Probability of selecting a Martian is 0.10, and the probability of the individual testing positive given their Martian is 0.85. The next part of that is 0.9 times 0.05. The probability of selecting a human is 0.9, and that human testing positive would be 0.05. Okay, now let's see what that gives us. That gives us a probability of 0.13. So when we set out to conduct this experiment, the probability, as we select someone at random, the probability they will test positive is 0.13. Now that we have that bit of information, we're ready to go here. It says find the probability that an individual is a Martian given that they tested positive. So there's a positive test result, but it could be a false positive. So we want to know what is the probability that, given the positive test result, the individual is a Martian. Remember, we want to use this formula. The probability of being a Martian given a positive result equals the probability of being a Martian and being positive divided by the probability of being positive. Or testing positive, that is. Getting a positive test result, that is. Okay? So that gives us 0.1 times 0.85 all over 0.13. And you can see, of course, the top is the intersection of Martian and positive, and that gives us a result of 0.65. So the probability, you've got a positive test result, the probability that the individual who was tested on, the probability they're actually a Martian is 0.65.